Lambdas, and higher order functions. Functions are powerful, but so far we have defined them and called them. What if we could pass them around like values, store them in variables? This is functional programming. Today we learn lambdas and higher order functions. In Kotlin, functions can be treated as values. You can store a function in a variable. You can pass a function to another function. You can return a function from a function. This might seem abstract. Why would you do this? Consider, you want to filter a list. The filtering logic varies. Sometimes you want even numbers. Sometimes you want numbers greater than 10. The pattern is the same. The specific check differs. You could write separate filter functions for each case. Or you could write one filter that takes the check as a parameter. The check is a function. Functions as values enable this flexibility. A lambda is an anonymous function, a function without a name. The syntax: braces containing parameters arrow body. Open brace x:"int arrow x times 2 close brace. This is a lambda that takes an int and returns it doubled. Open brace a:"int b:"int arrow a plus b close brace. Two parameters returns their sum. Open brace arrow println hello close brace. Two parameters returns their sum. Open brace arrow. If there is one parameter, you can omit the declaration and use it. Open brace it times 2 close brace. The implicit name is it. Lambdas are expressions. They evaluate to a function value that you can use. Every function has a type. A function that takes an int and returns a string has type parenthesis, int close parenthesis arrow string. A function that takes two ints and returns an int has type parenthesis int, comma, int close parenthesis arrow int. A function that takes nothing and returns unit has type parenthesis arrow unit. You can declare variables with function types val double colon parenthesis, int close parenthesis arrow, int equals open brace it times 2 close brace. The type tells you what the function expects and what it produces. Just like other types tell you about values, function types make functions first-class citizens. They can go anywhere a type goes. A higher-order function is a function that takes functions as parameters or returns functions. Fun apply twice with xint, an operation of type int to int, returning int, return operation of x. A apply twice takes a number and a function. It applies the function twice. Val result equals apply twice 3 with lambda id times 2. Start with 3, double to 6, double to 12. Higher order functions abstract over actions. Filter takes a predicate function. Map takes a transformation function. For each takes an action function. You provide the specific behavior. The higher order function provides the structure. When the last parameter is a function, you can move the lambda outside the parentheses. List of 1, 2, 3 dot filter parentheses open brace it greater than 1 close brace close parentheses becomes list of 1, 2, 3 dot filter open brace it greater than 1 close brace. If the lambda is the only parameter, you can omit the parentheses entirely. Run open brace parentale, run open brace parentale, run open brace parentale. This makes code read more naturally. The lambda looks like a code block following the function. Trailing lambda is syntactic sugar. The meaning is the same. The readability improves. When a lambda has exactly one parameter, you do not need to declare it. Open brace x arrow x times 2 close brace can be written as open brace it times 2 close brace. It is an implicit name for the single parameter. This reduces noise for simple lambdas. Most collection operations use single parameter lambdas. Filter open brace it greater than 0 close brace, map open brace it dot uppercase close brace. If you need a more descriptive name, declare it explicitly, open brace number arrow number times 2 close brace. Use it for short, clear lambdas. Some lambdas have a receiver, like extension functions. The type looks like int dot parentheses close parentheses arrow string. A lambda with int as receiver, returning string. Inside such a lambda, this refers to the receiver. This enables DSLs and builder patterns. Apply, run, and with use lambdas with receivers. Val result equals build string open brace append hello semicolon append space semicolon append world close brace. Inside the lambda, this is the string builder. Lambdas with receivers make configuration code clean and readable. Return in a lambda behaves differently than in a function. A plain return in a lambda returns from the enclosing function, not just the lambda. To return from just the lambda, use a labeled return, return at for each, or return at for each, or return at filter. Alternatively, the last expression in a lambda is its return value. No return keyword needed. Open brace x arrow x times 2 close brace. The result of x times 2 is returned. Open brace x arrow if x greater than 0 then x else 0 close brace. The last expression is the result. Let us summarize. Functions can be values, store them, pass them, return them. Lambdas are anonymous functions, open brace parameters, arrow body close brace. Function types describe what functions accept and return, parentheses, int close parentheses, arrow, string. Higher order functions take or return functions. Trailing lambda syntax moves the lambda outside parentheses. It is the implicit name for single parameters. Lambdas enable flexible, reusable code patterns.